How do you go from shipping tons of metal across the world to transmitting a part as secure data and printing it locally with full certification? That's the shift we're unpacking today. This is the Immutable Digital Thread, a framework that doesn't just enable additive manufacturing, but secures it end-to-end using cryptographic infrastructure. We're talking about a system where digital twin design, hashing, and real-time machine data are fused into a single, tamper-proof lineage. Before we jump into how it works, it's worth grounding ourselves in the actual failure points of today's distributed manufacturing model. Right now, the entire system is fragile at the digital layer. High-value CAD files are easy to duplicate, which makes IP theft a constant risk. Machine data, things like porosity scans or thermal profiles, gets trapped in silos, disconnected from the broader workflow. Certification bodies like European Aviation Safety Agency and Federal Aviation Administration still rely heavily on manual audits, which slows everything down. And as a result, companies overcompensate with inventory, storing slow-moving parts at high cost just to avoid downtime. So how do we fix this? The core idea is to treat distributed ledger technology as a trust protocol for manufacturing. At the foundation, you have cryptographic hashing, algorithms like SHA-256 generating unique fingerprints for design and process files. On top of that sits decentralized consensus, where network nodes validate parameters before a print even begins. The result is immutability, an append-only record of the entire lifecycle that regulators can audit without ambiguity. Now here's where it gets operational. Instead of relying on manual coordination between legal, engineering, and production teams, smart contracts handle the handshake automatically. A design is first tokenized to establish ownership. The system verifies conditions, payment, machine compatibility, certification requirements. Only then is a single-use encrypted license issued to the printer. Once the part is produced, the machine logs its data back to the ledger and certification is generated automatically. No paperwork delays, no manual bottlenecks. If you're wondering about scalability, because that's usually the first critique, this is where the architecture gets interesting. You don't store massive files directly on-chain. Instead, heavyweight data like STL files or CT scans lives off-chain in systems like IPFS, a decentralized peer-to-peer storage protocol where files are retrieved using their cryptographic hash rather than a central server location. The blockchain stores only hashes and metadata. That creates a cryptographic link between the two. If even a single vertex in a file changes, the hash no longer matches, and the system flags it instantly. That's your integrity check. What this enables is a complete shift in supply chain logic. Instead of make-to-stock, you move to make-to-order. Instead of shipping parts globally, you transmit secure data locally. And instead of relying on third-party trust, you rely on cryptographic consensus. Trust becomes algorithmic. To make that concrete, imagine a grounded aircraft due to a broken seat component. In a traditional model, you're waiting weeks for a replacement. With this system, the airline downloads a verified blueprint, prints the part locally, and gets an automatically generated compliance certificate tied to the process data. What used to take weeks now happens in under a day with full traceability. This shift is also creating entirely new business models. Local additive manufacturing hubs act as distributed production nodes. Engineers can monetize designs globally through secure marketplaces without losing IP control. And companies can even trade excess manufacturing capacity dynamically, turning idle machines into revenue streams. All of this drives real value. Immutability eliminates counterfeits and reduces liability. Traceability satisfies regulatory requirements natively. Automation removes administrative overhead, and localized production cuts emissions significantly, potentially reducing logistics-related CO2 by up to 85%. But if the upside is this strong, why isn't everyone doing it already? When you look at adoption barriers, the biggest issues aren't technical, they're human. Lack of skills and concerns around data privacy are the primary blockers. Things like scalability or resistance to change are really just downstream effects of those core gaps. From an economic standpoint, the ROI tells a compelling story. Building your own blockchain infrastructure requires significant upfront investment and only pays off after hundreds of parts. But using a Web3 SaaS model, essentially a cloud-based service that gives you plug-and-play access to blockchain infrastructure without having to build or maintain it, drastically lowers that threshold. You're looking at break-even after just a handful of prints, driven by immediate savings in downtime and inventory. Beyond cost, this system also bridges the physical and digital worlds through digital twins and product passports. Every printed part carries a verifiable history: materials, process data, QA results, all linked via blockchain. A technician can scan a tag and instantly validate the entire life cycle of that component. And this is just the beginning. We're already seeing integration with distributed AI, where predictive maintenance decisions are auditable. Sustainability tracking is becoming more granular, down to energy sources. Even training is evolving with immersive environments secured through tokenized assets. So when you zoom out, the Immutable Digital Thread isn't just a technology, it's a new operating model. It replaces trust with verification, manual workflows with automation, and fragmented systems with a unified, cryptographically secure pipeline. If you're working in additive manufacturing, supply chain, or digital infrastructure, this shift is already underway. The real question is how quickly you adapt to it. If you found this breakdown useful and want more deep dives like this, practical, technical, and grounded in real-world systems, make sure to subscribe.